Hello everyone. We are Team Technova with team ID C1315 participating in the SAMVED Hackathon 2026 organized by MIT Vishwaprayag University in association with Solapur Municipal Corporation, Solapur. The problem statement that we have chosen for this particular hackathon is Smart Safety and Assistance System for Sanitation Workers of Solapur Municipal Corporation. Before diving into the solution, let us first identify the major challenges that the sanitation workers face. Solapur being a rapidly growing city, sanitation workers play a crucial role in protecting the public health and hygiene. While doing so, they are exposed to various hazardous conditions, and some of the major challenges that they face are listed below. The first major challenge that we have identified is hazardous manhole condition. In order to carry out cleanliness activities, the workers often need to go into manholes where they are exposed to unsafe environment and toxic gases which might lead to suffocation and fatal accidents. Apart from that, manual and high risk of operation, since most of the cleanliness activities are usually carried through manual ways, this leads to increased risk of operation wherein the person needs to enter into manholes and drains to carry out cleaning activities. Apart from that, overwork and fatigue may also be another major challenge that the sanitation workers face. That is, long working hours and uneven workload distribution can increase physical exhaustion, thereby increasing major health related issues. Apart from that, whenever they are working in such unsafe environment, if any casualty happens, there is always a delay in the emergency response due to lack of contact between the workers and the centralized authorities. So this becomes another major challenge that the workers face. So, what is our solution in order to overcome all these problems? We are planning to build a hybrid hardware software safety system for sanitation worker, which integrates manhole hazard detection, workforce monitoring, and centralized supervision. So, what happens? What is our solution? Is that we are planning of using some of the environmental sensors in order to sense the surrounding environment of the workplace, thereby if the surrounding environment becomes hazardous or dangerous to the worker, an immediate alert systems can be developed. Apart from that, in order to have proper work hour distribution among the workers, we have planned to carry out some of the workforce monitoring tasks which we'll be discussing in the further slides, and also enabling centralized supervision so that the municipality authority can monitor the work conditions of each and every employee in the sanitation department. Apart from that, this also connects sanitation workers, zonal supervisors, and central control platform. So, how is the issue solved? Detects the hazardous manhole conditions before and during sanitation work. Since we have multiple sensors deployed in the work location, this can detect hazardous manhole conditions whenever a person is carrying out sanitation activities in that location. Apart from that, it also prevents fatigue related risk through work hour monitoring. So, we have proposed a system that will continuously monitor the work hours of the employee, thereby preventing the employee from overworking and which might lead to fatigue related risk. This is prevented by our system. Apart from that, in case of emergency, fast emergency response system has been established through SOS alerts. Apart from that, we have improved supervision through zone-wise visibility. That is, we have planned to divide the entire Solapur city into multiple zones, and each zone will have a zonal supervisor who will control and coordinate the work distribution of the work among the sanitation workers, through which we can improve the work hour balance of the employee and also improve the supervision through zone wise visibility. So, what is our Originality and innovation in this, we combine the environmental safety, operational safety, and emergency response associated with the sanitation workers of the municipal sanitation operation. We also use low cost hardware with scalable software architecture in our solution. So what are the technical approach that we are using? So we are planning to use Raspberry Pi as the main control unit of our sensory data associated with gas and environmental sensors which are deployed in the workplace of the sanitation worker, thereby continuously monitoring the conditions in and around the workplace. Apart from that, we have planned to design a web-based dashboard for municipal and zonal supervisors so that they can monitor the working of each and every employee. Also, we have planned to develop a mobile friendly application which is easily accessible and has high learnability for sanitation workers, that is they can easily adopt to the functioning of that mobile application. Also, we have used a backend database for sensor data, work logs, and alerts of the sanitation workers. The procedure is simple. The sensors will continuously monitor the manhole condition. If there are any unsafe condition, automatic triggers are or alerts are sent to the controlling authority. Then we have divided the entire location into zones, and hence the zonal supervisor will assign the tasks to the based on the zones to the workers, and hence the workers will have a good work life balance. Workers have to log their shift start and end time, thereby preventing the workers from overworking or even underworking and getting the labor done as per their physical capabilities. Next one is backend will calculate the total working hours using safe work hour threshold. So what is safe work hour threshold is based on the age and physical capabilities of the employees. What is the safe working hour duration for a particular sanitation worker is computed, and he has to work only for that specified amount of time, thereby preventing overwork and even underworking. And workers can also trigger SOS alerts during emergency if they feel unsafe in any of the situation. So this is our system architecture, wherein we have the field layer on which we have the mobile app and the manhole safety unit. Manhole safety unit uses different sensors which are directly connected to the Raspberry Pi, which will act as the controlling unit. Apart from that, a mobile app that is available with the municipal workers who will which will have features to register and has profile of the workers, start and stop the shift as and when they start their work and end their work, and SOS emergency system in case of emergency is present in the mobile application. This app is the data from this app is sent to the backend through mobile network, wherein the backend processes the sensory data and also does work our calculation, safety rules and regulation, and also in the management and also provides a management layer wherein we have a central control unit and zonal supervisor, and their related tasks are divided among them. Zonal supervisor has the work hour monitoring, worker status, and real-time hazard functionality associated, and the central authority controls the overall city overview, safety analytics, and emergency alerts. So the core modules of our system are worker registration and safety profile, wherein the worker will register himself and his day-to-day activities will get logged. Manhole health detection through the sensory data. Work hour and fatigue monitoring through the logging of the start and end time of the shift, thereby tracking the workload and total working hours. Zonal management model, that is uh, we as I said, we have planned to divide the city into zones, thereby improving the modularity and thereby bringing out more efficiency in operation. And SOS and emergency alert module, wherein in case of any emergency, the workers can get a one tap SOS alert sent to the centralized authority for any safety purposes. So, this is how we have planned our solution. Thank you for your time and patience.